Welcome, my dear students in Prep 2. Our session today is the first lesson in geometry. It's about equality of the areas of two parallelograms. This lesson, we will explain this lesson in two parts. The first part in this session and the next one, next session, inshallah. Okay. At first, I want to talk about the parallelogram. We studied parallelogram in primary 6. We said that parallelogram is a quadrilateral in which each two opposite sides are equal in length and parallel. Each two opposite angles are equal in measure, and each two consecutive angles are, or the summation of each two consecutive angles equal 180 degrees. Also, the diagonals bisect each other. Okay, today we want to know what do we mean by the altitude of a parallelogram. Okay, here for example we have a parallelogram ABCD. The altitude of the parallelogram is the line segment drawn perpendicularly, like here, from D to CB, from this point to the opposite side, perpendicular to the opposite side. But we know that AD is parallel to BC, and the distance between any two parallel lines is constant. That means that YB equals XF equals DE. Okay, all this length is the height of the parallelogram. Okay, we can consider any side of this parallelogram as a base. Okay, for example, if you considered BC is a base, then DF is the corresponding altitude or the corresponding height. If you considered AB as a base, then DE or H2 is the second height. So any side of the parallelogram can be considered as a base. The parallelogram has two different heights. The smaller height, as you can notice from this figure, the smaller height is corresponding to the greater base, and vice versa. The greater height is corresponding to the smaller base. Okay, so the smaller height corresponding to the greater base, and the greater height corresponding to the smaller base. And we studied before that the area of the parallelogram equals the base length times the corresponding height. For example, here, the area of this parallelogram equals AB times H2 or CB times H1. Okay, so that means the area of a parallelogram equals smaller base times greater height or greater base times smaller heights, according to the given in the problem. Theorem number 1 said that the surface area of two parallelograms with common base and between two parallel straight lines, one is carrying this base are equal in area. So, two parallelograms can be equal in area if the two conditions here is satisfied. The first one is that they have a common base. The second one, they are between two parallel straight line and one of the parallel straight line carrying this base. Let's take an example to clarify this point. Look at the figure here. In the opposite figure, ABCD, this is ABCD, and AFED are two parallelograms. C belongs to BE, and F belongs to BE also. And AF intersect DC equals G. The two sides AF and DC intersect at point G. Prove that the area of the figure ABCG, look at here, ABCG, this figure, the area of this figure equals the area of DEFG. So this part, the area of this part I want to prove that the area of this part equals the area of this part. Okay? Okay, let's begin. At first, I write the given and I write the required to prove. The given, of course, is this part. I won't write it again. And the required to prove is the area of the two figures are equal. Okay? How can I prove that? Look at this figure. We have two parallelograms. Okay? The parallelograms are equal in area. Why? We said we have two conditions. The parallelograms has a common base. AD is a common base. AD is a common base. Okay, this is the first condition. The second condition, they are between two parallel lines. AD parallel to BC and C, and also B and C, F and E are in the same line. So AD parallel to BE. That means the two parallelograms are between two parallel lines and they have a common base, and this common base carried on one of the two parallel lines. So the two parallelograms are equal in area. Okay, since the parallelogram ABCD and the parallelogram AFED, the red one and the blue one, have a common base DA, and between two parallel lines, what are the parallel lines? EB and DA. Then the area of the two parallelograms are equal. So the two parallelograms are equal in area. But I don't want the area of the two parallelograms. I want the area of this part. Can you see this part? ABCG, and the other part DGFE. I want to prove that the two areas are equal. Okay, the area of this part will be the area of the parallelogram, but without this triangle. By the same way, the area of the next part, or the second part, also equals the area of the parallelogram here in blue, but without this triangle. So, I subtract the area of the triangle AGD from both sides. Here in number 1, I subtract from here the area of the triangle AGD, and from here also the area of triangle AGD. Okay, the area of the parallelogram ABCD minus the area of the triangle AGD will be the area of the first figure ABCG. The area of the parallelogram AFED minus the area of the triangle AGD will be the area of the second figure DEFG. Okay, so this is what do we want to prove. Okay, let's continue. We have some importance carries. The parallelogram and the rectangle with a common base and between two parallel straight lines are equal in area, of course, because the rectangle is special case of parallelogram. Number 2, the area of parallelogram equals the base times the corresponding height. The parallelograms with bases equal, if you have many parallelograms and their bases are equal in length and lying on a straight line. Okay, while the opposite side of these bases are on another straight line, the parallelograms will be equal in area. Okay, so if you have many parallelograms with the same base length and between two parallel lines, they will be all equal in areas. Okay, let's solve this exercise. Complete a parallelogram whose base length is 12 centimeter and its corresponding height is 3 centimeter, then its area equals what? Let's remember, the area of the parallelogram equals base length times corresponding height. So I'll multiply 12 times 3, which is 36. The area of parallelogram, the base times the corresponding height. Okay, the next one. We have the area of the parallelogram here, 72. And the length of the base is 9. The length of the base is 9. Then the length of the corresponding height will be, now I want the corresponding height, so I'll divide the area by the base, okay? So I'll divide the area by the base. 72 divided 9 equals 8. The last one, ABCD, is a parallelogram in which we have AB 6, BC 12. So I have two bases. The greater base is 12 and the smaller is 6. And its greater height is 4. The greater height is 4. Okay, let's remember the rule. We said before, the area equals the smaller. Okay, the area equals the smaller base times the greater height, or the greater base times the smaller height. Okay, so the smaller base times the greater height. Here we have the greater height is 4 and the smaller base is 6. So I multiply 4 times 6 to get the area of this parallelogram. Okay, so the area of parallelogram will be 4 times 6, which is equal 24. Okay, so to calculate the area of the parallelogram, okay, we will multiply the greater base by the smaller height, or the greater height with the smaller base. Okay, that's all about our session today. Next session we will continue part 2 of equality of the areas of two parallelograms. Thank you very much for watching. See you next session and goodbye.